Okay, now some least squares examples. I was thinking that I hadn't really used least squares that much, but after I thought about it a little bit, yeah, I came up with at least two examples. So, a first one was that I looked at a model for burning calories from fat while running. And, it's a pretty simple idea. It was for things like a college algebra class that I was doing this because we were interested in thinking about functions and what they looked like and so forth, and algebra functions like composition and so forth. So, what I was able to do in terms of data was I could find, in general for any given fitness level, I could find running rate as a function of time. And where I used least squares was, well, as you might guess, that sort of looks like that. And so I used least squares to come up with a functional model that looked like that. And I think that was it was probably some sort of exponential, but it could have been some kind of power function with like a square root, or not a square root, a power function with a negative exponent or something like that. But I could find running rate as a function of time. I could find calories. Keep wanting to do an A there. Calories burned per unit time as a function of running rate. So if we come up here and we say, like running rate, so R is a function of T, something like that. Now here, this was like calories burned, so, C is a function of R. And again, I had some sort of data, and I used least squares to come up with this function. Well, now see, if we do a composition, C of R of T, we have calories per unit time as a function of time. But I had mentioned calories from fat. Well, I was also able to find percentage calories from fat as a function of exercise time. So here was some P of T, and so what I was able to do then was get my final answer of C of R of T times P of T. But here I just used least squares. It was an empirical model. I wasn't really looking at the mechanism that caused that to be the shape it was, nor these, you know, the C of R or the R of T. I think it's the C of R is really linear. I think it was, which really surprised me. But at any rate, you know, then I came up with that overall function after doing the least squares on each of these. So that's a way I've used least squares.